This question is asking the average rate of change question in a backwards manner. Okay, you see they're giving you the function and then they say which interval right here would give you an average rate of change of 0. Now there's two ways really to do this. The first way is the easy way, but it's the longer way, and it's probably the way that you thought of. Okay, first off, let me point out that this right here is an interval, but it's written in inequality notation, which is not the same way that they were writing the problem in the other problems. Okay, they were writing them like this. They were using the brackets. This is called interval notation. This is called inequality notation, but they're saying the same thing. The -2 and the 4, those are both the independent variables, usually known as the x's, but in this case, they're the t's. And then all of these intervals right here are the same, essentially. So one way to do it is to take each interval and find the average rate of change for each of those intervals, for that interval. So like the bottom one, you would take the 1 and the 4 and you would subtract them because those would be the run of the slope. And then you would find the y values first to find the -4. You would plug 4 into the t. 4 minus 1 is 3. 3 squared is 9, and then this is a -9. So adding 5 to -9 will give you -4. And then to find the other y value, you would have to plug in the 1 back into this and do the same thing. And when you do that, you would get 5. Simplifying it, we get -9 over 3, and then we get -3. And so we would see right away that this one doesn't work. And then we would have to guess and check the next one. Then we would have to guess and check the next one, guess and check the next one until we get a 0 for the average rate of change. As you can see, it is easy, but it does take a long time. There is another way, and that's only if you can understand, if you do understand how to graph this function using transformations, okay? So here, let me show you that really quick. Now, you should know something about quadratic functions. Quadratic functions are polynomial graphs. That means they have symmetry. They have symmetry about the middle part, which we commonly call the axis of symmetry. And so if you were to pick an interval like this x value to this x value, you can see that they're perfectly symmetrical apart. And all the points between the interval would all have an opposite. So like this point right here and this point right here, they would have exact opposite rates of change. So like if this one was a -3, that one would be a +3, and you can see they are opposites. When you add these two, you get 0. And so if you were to find the average rate of change, when you subtract the y values would be the same, so you would get 0 on the top. And so you would have 0 divided by something, and then you would get 0. And that's what we're looking for. Which interval would have an average rate of change of 0? And so you can see that if this was the first number in our interval and this was the last number in our interval, if they were perfectly centered over the axis of symmetry, you would have an average rate of change of 0. So let's take this guy, for example. How would you graph this guy? Well, we always start at the origin when we're using transformations. And then you would see this -1 right here, and that would move us over to the right one. And then the +5, that would move us up 5. And there's our new vertex. The negative right here would make our parabola go upside down. And now you can see clearly where our axis of symmetry is. Our axis of symmetry is at 1, x equals 1. And so which of these intervals is centered over this axis of symmetry, this 1? After looking and thinking for a minute, you'll see that -2 and 4 would be perfectly centered at 1. And you can tell because there's 3 spaces to the 1 from the -2 and the 4. And now you have your answer. Okay? Now, what if you didn't have this form? What if it wasn't in vertex form? Or actually, no, let me not ask that question yet. Can we look at this function and know that the axis of symmetry is at 1 without even having to do all this work? And the answer is yes, just by looking at this -1. When you shift the function left or right, you are just changing the axis of symmetry. And so then you would know that x equals 1, and that would be the axis of symmetry without graphing. But what if you weren't given this form right here? What if you were given a standard form, standard polynomial form? So I'm going to take this and I'm going to rewrite it so that it's in standard polynomial form. First, I have to expand the exponent, then I multiply. And after I multiply, I do a little bit of simplification. Then I add like terms. And then I have the same function, but it's now in polynomial standard form. Okay, now if you have this form, it's not easy to see what the axis of symmetry is. So we have a cute little formula for that. And I'm not going to prove the formula, I'm just going to give it to you right now. The formula for the axis of symmetry when you have a standard form is negative b over 2a. So x would equal negative b over 2a. So you have to know what the a and the b are. The standard form right here gives us an a that equals negative 1, a b that equals 2, and a c that equals 4. Okay, and you know that if you know the general form of a standard form polynomial in standard form. So it goes ax squared, bx, and then c. So your ax squared is, well, it's actually a t, not an x. Your a is negative 1, and then right here it's not an x, it's a t. Your b is 2, and then your c is 4. So that's how I knew these letters right here. This function up here also is a standard form, but it's known as vertex standard form. And that would have an A right here, an H right here, and a K. There's also a B that we could throw in there, but we don't need to worry about the B right now. This guy is called standard form, or standard polynomial form. And then the other one up there, that one is called standard vertex form. All right. Now, let's get back to finding our axis of symmetry using this formula. So because we know the B and the A, we can plug it into our formula. The A is negative 1 and the B is 2. A little bit of simplification gives us 1, which is the same thing that we got over here. So 2 ways to find the axis of symmetry. Actually 3 ways. You can graph it, you can look at the H, or you can use negative B over 2A.